Welcome one and all, Coach Jay. Hope you're having a fantastic day. This is Precalculus, Chapter 3. Let's get started. Hey, we've got March Madness action going on, and we've got a lot of excitement, one of which is a test on Friday. And I want to make sure that we go through the necessary specifics so that we hit all the things on the test here. So without further ado, we're going to get right straight into the test stuff. Some of this is on your review. Some of this is not on your review. Regardless, we're going to try to hit some of these and review them together. So with that being said, let's get started. And let's pull this up and let's get it rolling here. All right, so the first thing that I want to make sure I review is one of these graphing problems, largely because we'll be on the test and because there's really like 4 different things that you need to know in terms of graphing this log, okay? So let's talk about the first thing. We have a domain. Second thing, we've got our transformations that you'll need to know. Third, the asymptote, okay? Abbreviate it. And the fourth, we're going to graph it, okay? All right, so let's do this real quick. We're going to graph the log graph. First things first, let's make sure we have the transformations. Well, because of the fact that we have a +2 on the inside and a -1 on the outside, we're going to push this thing left 2 and down 1, okay? So there's our transformations. The next thing we do is try to take away the transformations to where we're left with y equals log base 2 of x, okay? We then try to get that x by itself by simply shooting 2 to the other side. And once we do, changing it to that exponential form, we get 2 to the y equals x, okay? So with that being said, we've got our x and y t-chart. Big thing with this x and y t-chart is plugging in for the y values, especially in the log form. We got -1, 0, 1, and 2. 2 to the second power is 4. 2 to the first power is 2. 2 to the 0 power is 1. And 2 to the -1st is simply 1/2. So when I graph this, make sure you understand that we do first the x, then the y. So we go 1/2 comma -1. So we're going to come over here. While I'm writing these, remember too that the asymptote is traditionally a vertical asymptote at 0. We call that x equals 0. And now we're going to go right 1/2 down -1. The next one is right 2 up 1. The next one's right 4 up 2. To where this graph kind of slowly goes downward. And it will look something like that. Almost like, well, it is an inverse of an exponential function. But we're not quite done yet, because now what we need to do is actually figure out what happens once we transform it. So now what we do is we're going to change all of these points in the vertical asymptote. Even though if it goes up and down, it will be transformed down 1, but it doesn't change anything. What does change it is when you push it left 2. So instead of at 0, this thing is going to be at -2. So we'll say x equals -2 there. And then all of these points will go left 2, 1, 2, and down 1. This will go left 2, 1, 2, down 1. And last, we'll go left 2, down 1. So this graph will look something like this right here, okay? All right, so the red one really is the answer for our graph on this new one once we've transformed the original. The domain would be the furthest left is -2, doesn't touch it, so we do a parenthesis. And the furthest right it goes is infinity, so we'll put that infinity with the closed parenthesis on it, okay? All right, the second one that I wanted to hit on is how do you use your calculator with the regression function? And if you could just take a snapshot real quick, we're going to do number 17, 17 here. And the reason why I tell you that is because I think it might be helpful in the context of the problem here is we're going to pull up our calculator. The big thing to remember, though, too, is 17 is that the x values would be the 0, 1, 2, so on and so forth. And the L2 would be your y list. And so we'll hopefully help you with what to do with this and how to plug it in as it comes up here. I'm going to kind of minimize this and go ahead and screen share this again. Hello, one and all. Let's see. I want to go here and application window. Pull this up, which pulls this up. Okay. Let me make sure. That might not have done what I wanted to here. There we go. And we're going to share this. Okay. So the first thing we want to do is we want to go to Stat Edit and go up to L1 and just simply press clear. And then when you go to the down arrow, it just gets rid of it. Same thing, clear, down arrow gets rid of it. Okay. In the L1 list, what we would like to do is plug in, and I'll throw these down for you real fast here. We'll go 0, 1, 2, 3, 4 was the first few. 0, 1, 2, 3, and 4. And the L2 list was 10, 6.1. It's decreasing here. The question is it decreasing at an exponential rate or at a linear rate? We're going to look and see here. 3.6 it should be. Okay. Now, once I get to here, make sure that you go to second y equals. Make sure your plot is on. If you were to graph it, let's say I were to graph it, you'll see that there's nothing there. So we always go to zoom, stat, which is number 9. And there it is. It's an exponential decay function there. So as I go back to stat, we're going to go down and we're going to calculate the exponential regression of this L1, L2 list. Notice it has L2, L2. Just make sure I put in L1. So second one, which states it's L1. Go down to calculate. And when you write this down, you will literally put y equals 8.46 times, okay, now I'll write this down here, 8.46 times parenthesis 0.778 to the x power, and that equals y. And that's how you would solve or find the regression line that's there, okay? So, again, just wanted to make sure I gave y'all a heads up on that. But that's how you would solve for number 17 there. Number 2 is one where it says an initial deposit of $1,000 was given into an account that compounds quarterly. I will tell you, the formulas that you really just need to know, the only ones you need to know other than log to exponential and exponential to log, is this formula, 1 plus r over n to the nt. And then you have the PERT, which is compounded continuously. Just remember that, okay? So in this example, it says an initial deposit of $1,000 was given into an account. So 1,000 is going to go in for P. For 10 years, so 10 is what T is here. Remember, 10 is always what we plug in for T. That compounds quarterly. So quarterly means that we are going to be plugging it in for n. If it said continuously, we'd be using the wrong formula. We'd actually have to come back up here, okay? So the question on A says, based on that information, what is the rate needed to double in 10 years? So we're trying to double the amount. So now we are going to take 1,000, changing it to 2,000, and we'll just say equals 1,000 times 1 plus r over 4. It's quarterly to the 40th power. So to kind of set this up, we're going to divide this by 1,000 on both sides, producing a value of 2. And so 2 is equal to 1 plus r over 4 to the 40th power. Now, it's a little tougher here because to the 40th power, and this 4 kind of throws me off a little bit. We've got to get rid of the 40th power. So to do this, we're going to change, or on both sides, I'm going to take this to the 1/40th. Okay? So 2 to the 1/40th power. And hopefully this will help out here. To the 1 divided by 40. It's like 1.017 something, okay? So, and you could write that down. You could actually do it 1.0175, equals 1 plus r over 4. So now we solve for r by subtracting by 1 on both sides, right? And then we say r over 4 is equal to the 0.0175. So then we can multiply this both sides by 4 here. And once I do, I get a rate that's 0.0699, or we could just say 6.99%, or 7% rounded would be fine as well. Okay, but that's how we would approach this. The big thing is if the variable was in the exponent, we might have to change that to log form. So just a heads up. If you did part B, the only difference with that is the time. Here, I'll circle what's new. They're trying to see what A would be. So coming back to this formula, what is A if the rate was 7%? And now the time would be not 10 years, but 40 years. And so the blue part is what I would do differently to solve for my new A. Okay. Hopefully that's, again, another rep for you there. Now I'd like to just go through some ones on our review sheet, make sure that we understand the processes here. Number one is one that many people will try to do a one-to-one function on where we get both bases alike, but in this context, we're not able to do that. So in order to solve this, we've got to change this from exponential to log form. So remember the log and exponential, those are the kryptonite, whereas ln and e are kryptonite, okay? So those are kryptonites of each other. So in order to change this, we shoot the 3 to the right side, producing 5x plus 1 on the left equals log base 3 of 5, okay? Now, in solving this, we're trying to solve for x, and in doing that, we have to get log base 3 of 5 on the right side by doing what we call the change of base formula, which is the log of the outside, the 5, divided by the log of 3. And make sure you put those in parentheses on your calculator. So we'll do the log of 5 divided by the log of 3. And I got 1.465. So in bringing this down, I'll just say that 5x plus 1 is equal to 1.465. So now I can just solve it normal by subtracting by 1. And then dividing by 5 on both sides. So I'll get 0.465 equals 5x. Divide by 5 on both sides, producing 0.092, well, it's really kind of 3, we'll say. 0.093 as my answer for x, okay? So that's how I would do part 1. We did part 2 already, very similar. The only difference with this one is it's our PERT formula. The initial deposit, my P is 3,000. So let's do our A equals PE to the RT power, where 3,000 would be my P. The balance will double in 7 years. So double over the course of 7 years. So we're going to have 6,000 as my A. And then this would be E to the power of R times, and T would be, would they say, 7 years. Okay. So how can I solve for my rate? That's the question. Is there any way that I could solve for rate? Well, if I divided by 3,000 here, divided by 3,000, this would be 2 is equal to E to the power of 7R. Okay. And then once I get to this point, we're trying to get E by itself. The reason why we get that by itself, we then want to take the ln of both sides. But I can't do that until I get rid of that 3,000 and get that E by itself. So we could just say, okay, ln of 2 is 0.693. This cancels here. Little cancel party. Woo-hoo. Little pi party. Divide that by 7. We get 0.099 for R. So when I divide it by 7, R would be 0.099, or we'd say 9.9%. Okay? In this case, would be D. All right, I'm hoping this is helpful for you as we continue down through some of these. I do want to do numbers 3 and 4. The big thing is just kind of how do I set this up? How do I approach it here? The only thing that I will tell you is if you get two numbers at the end that are one's positive, one's negative, just test it in for x and make sure that you do not get a negative log out. I cannot have a negative log, and so just be very leery of that. In the context of number 3, though, very similar to number 4, we need to combine logs together in order to simplify. And so I combine them when they're added by multiplying the 7 minus x and 3x plus 5. So what we have on the left side is log base 8 of 7 minus x times 3x plus 5. And this would be equal to log base 8 of 24x, okay? The log base 8s, notice that those cancel out. The reason why they cancel is because there's only one on each side, nothing else. And since they have the same base, we're able to cancel those out. And then from here, we want to solve by just distributing. So we'll get 21x minus 3x squared plus 35 minus 5x equals 24x. Probably we'll subtract this 24x on either. Well, actually, let's do this. Let's combine. I've got negative 3x squared plus 16x plus 35 equals 24x. And really all I'm trying to do here is get this x squared to where it's positive. So I would like to add 3x squared, subtract 16x, subtract 35, all onto the other side so that we're able to either factor or we can use the quadratic, whatever floats y'all's boat there, okay? We got 3x squared plus 8x minus 35. But from here, again, you can look on the answer sheet, but from here, we want to use the quadratic or factor to be able to get what our answers are there. Just be careful. The negative answer will not be able to be plugged in because that would produce a value that would be undefined in the case of a log. So just be careful of that. Number 4 is similar. However, we can't simply just get rid of the log base 2, mainly because as we look at this one, we can just do, okay, so log base 2 of x times plus log base 2 of x plus 3. We could just multiply x and x plus 3. So we're left with log base 2 of x times x is x squared. X times 3 is 3x. And that equals positive 3, okay? So in solving this, we can now change this by shooting the 2 over to the right side, making it x squared plus 3x equals 2 to the 3rd, which is 9, okay? If I subtract 9 on both sides, I'm left with x squared plus 3x minus 9 to solve this. And from here, we will use the quadratic formula just like I did over on the right-hand side, okay? This one, I don't think you can actually solve this by factoring, but you can use it. Use the quadratic formula. Remember also the negative value will not be able to be solved for here. So just the positive value, mainly because I can't substitute in for x there, okay? All right, that's a lot of information. I know I'm going pretty quickly through this, but hopefully this is helpful. Number 6, you should be able to do. Make sure you check that out. Plug 5 in for t. We should be good here. Number 8, I'm going to come back to 5 and 7. I says, which of the following equations is not true? Well, e to the ln of x, that is true. Those will cancel. X equals x. Log base b of b equals 1. That is true, so we're good there. Log base 1 of b, that's incorrect, okay? What it is if I had log base b of 1, that is equal to 0. Anytime this value is 1, that will always be equal to 0 there. But that b is incorrect, so that would be the correct answer there. On 5 and 7, these two are two that we're trying to expand out, similar to number 9. Number 9, we're going to look at one similar that we just did there. I'm just going through these. Check out number 11, and I'll come back, so just a heads up. Number 12 is similar to one we're about ready to do. I think 14 is the same one that we just did, didn't we? Yeah, 14 and 10, I think, are the same one. So we'll do this one. So I'm going to do 14 This one here, notice the asymptote is at now -5, so it was an exponential that shifted down 5. That's why this A, which would be normally at 0, that horizontal was shifted down to -5. That's why A would be the correct answer. Here, notice that it was at 0, but shifted to the left 3, so I need a horizontal shift that moves it left 3. The only one that does that is D there. So just a heads up on that one. So again, I've got 14 that I'm doing. Domain and range, this one right here, we can look at this one. Maybe if you look at it tomorrow morning in class, that would be a good one for a challenge question for tomorrow. Again, just kind of a heads up there. Number 16, again, good challenge question, maybe one to look at there. 17, just a strategy. We want to change 16 to the change, or we could do 1-to-1, where we change 16 to where it's 2 to the 4th. And then remember, after that, we could cancel out the 2's and solve. You could also use your calculator and make it into exponential form as well. On 18, this is a log graph. Notice here, this is at -1 here, or at +1, I'm sorry. So this is a log graph here that comes downward. So E's would not be ones that I could use because that's exponential. And since it moves it from what was 0 to the right one, that's why D would be my correct answer, because that shifts it to the right there 1. On number 19, remember too, you want to combine these two together, but remember that when we do, you can do that, but you'll have log of 3x plus 7 multiplied by x minus 2, and that equals 1. I want to get this out of log form, but to do that, this has a base of 10 that gets shot over to the other side, and it produces the 10 to the 0 power once I do that, and then I solve using the quadratic again. And then number 20, I know I'm going quick. I'm going to go back to these other ones here. On this one, we have e to the 2 ln of x plus 1. Notice I can't just simply throw out ln and e yet. I've got to get rid of this 2. But by rule, if the 2's in front of the ln, it can shoot to the backside, making this e to the power of ln of x plus 1 squared, right? Because it comes as a power. It's that power rule. Since e and ln are now back-to-back e's to the power of ln of something, that can cancel, producing x plus 1 squared, okay? All right, I hope that was helpful. Look at the other review sheet there to continue there. I did want to do number 14, and I wanted to do number, I thought there were 2 more, 14, 5, and 7. Okay, let's look at 5. 5 is one, if I have the square root, we're going to make the x squared over y to the power of a square root, which is power of 1/2, okay? Now, by rule, if it is to a power of 1/2, that 1/2 gets shot to the front by the exponential rule. Because it's applied to everything, we want to do this part first, okay? So we shoot it to the front, producing 1/2 ln of x squared over y. Now, in moving forward, we want to now expand this. And since we have x squared and a y, x squared over a y, I can expand this because I have x squared over y. We can divvy it out with a subtraction sign. So we would be left with 1/2 ln of x squared minus 1/2, make sure it goes to both, ln of y. And 1/2 ln y looks good here. There's nothing else left here. But the squared can get shot to the front. So 2 times 1/2 is just 1, leaving us ln of x minus what we had left over, 1/2 ln of y. Number 7, similar. We're trying to now bring it as one identity. We do this by taking the numbers that are in front. There's not one there, but these numbers in front are shot to the backside as a power. So we're left with log base b of 16 to the 1/4 minus log base b 5 to the second plus log base b of 7, right? Now we could simplify this. 16 to the 1/4, one number multiplied by itself 4 times gives me 16. That answer is 2. So we're left with log base b of 2 minus log base b, 5 squared is 25, plus log base b of 7. Okay, so we remember that anytime I subtract something, that is the number that goes into the cell, right? It goes to the bottom. So we're trying to get this as 1 log base b, of, and the 2 is what we started with. And because we subtract here, when I subtract a log base b of 25, that 25 is what goes to the bottom. And then because I add here on the back end, that 7 remains at the top, because anytime it's positive, it remains at the top. So the answer would be log base b of 14 over 25. Okay? All right. The last one that I wanted to hit on was number 10. Okay? Number 10 is a weird one, mainly because normally you think, oh, log form, we could change that to exponential form. But as I looked with Dalton yesterday, and Chris, and a couple others of you, there's a better way to kind of do this, and really there's multiple ways to do this. But one thing that I would recommend is if I see something that has a log in it that does not have a variable, the easiest thing to do is simply simplify this by either doing log of 32 over log of 2, or you could take log of base 2 and make 32 2 to the power of 5, because this right here in parentheses is 32. A log base 2 of 2 cancels out, producing a value of 5. Both answers will give you 5 here for that log base 2 of 32. So now I've got x squared minus 4x equals 5. Subtract 5 on both sides. Getting x squared minus 4x minus 5 equals 0. So I could factor, it's minus 5x plus 1, set equal to 0, to where x is equal to 5 and negative 1. And actually, both of those are correct answers, even though normally we say no negatives in logs, because there's no x variable in this log. Any value will be actually okay. So actually, 5 and negative 1 are good to go. Hey, I hope that was helpful for you. I hope that we went through some good stuff there, and I appreciate your consistent effort, consistent work. I've really seen y'all really work hard, and so good on you. Hope your bracket does well. Hope you have a great week, great weekend, and tear this test up tomorrow. See y'all. Coach Jay out. Bye.